Yo guys, what is up? It is Gamer123ST here. Today we're back with another video, and just as I promised in our video where we scored 106 in cricket forever, I am making our Saturn video. This is Saturn Space Series Part 7, and I'm Gamer123ST. Without further ado, let's get started. Now, Saturn is the second biggest planet in our solar system after Jupiter, and it has a diameter of 116,604 kilometers. Yeah, 116,460 kilometers. And it's also the least dense planet, but I already told you a little bit about this in the solar system video, but it wouldn't hurt if I told you again. So Saturn, if you just drop Saturn in water, it would float. Now, this is not possible on Earth because Earth does not have enough water to cover the surface area of Saturn. Because if you have the diameter or surface area, let's say like the bottom of Saturn, which would be like as big as Uranus or something, that diameter, we'd have to have as much as diameter we'd need on Earth. But let's just give you a fact here. Earth is not even as big as that diameter. So heck no, there'd be no hell of doing that on Earth, because even if we did, we'd all be dead, because that's not gonna be safe at all. And Saturn is obviously the sixth planet away from the sun, because by now you probably know it. If it's Space Series Part 7, then the planet is that many number of planets away from the sun. Like, let's say, for example, let's take Earth. It's the third planet from the sun, and it's Space Series Part 4. Mars, fourth planet from the sun, Space Series Part 5. Because if it would have been the same, except I added that small episode about Saturn, the solar system, for that little amount of time there, that would extend the episode and make it so that Saturn is now not as big. Or no, I'm talking about that. Now Saturn is Space Series Part 7, but it is not really the seventh planet away from the sun, because we are doing one extra video at the point. Okay, enough of that. Let's actually get into what we're talking about. Saturn is the sixth planet from the sun, which has a distance of 1.434 billion kilometers away from the sun. Okay, we got some fact. 1.4 billion kilometers, which means it's 2 times more than Jupiter, and we officially crossed the mark of 1 billion kilometers away from the sun, and that is a great thing. Anyway, so Saturn is the second biggest planet in our solar system, but one thing is it also has 62 moons, and its biggest moon is Titan, which also has a diameter of 5,149.5 kilometers, which is just a little short of Jupiter's Ganymede, but which means it's also the second biggest moon. And now, out of its 62 moons, let's just get into the talk of this, now that we're at it. Alright, let's start from that bottom left corner. Helene, and then we got Epithemius, Prothemius, what's that one? Janus, Dione, Tethys, or Tethys, I don't know, Claudius, and then we got Titan, Iapetus, Rhea, Mimas, Hyperion, Methone, Pandora, and Calypso, and then we got Saturn at the end there. So those are the main moons of Saturn. They're not all 62, because I just read that in that short amount of time. You would obviously know it's not all 62. And also, Titan's diameter is 50% larger than Earth's moon, making it among the largest natural the satellites in the solar system. So a round of applause for Titan. And also, since we're talking about Titan so much, why not just, this is Titan, Saturn's biggest moon. So back to this photo. A day on Titan is the same time it takes for the moon to orbit around Saturn. So it would take about 15 days, 22 hours and 41 minutes. Now, basically, Titan has not that much of like a day, because I'm talking about like Jupiter's Ganymede and Callisto. They'd have like one circulation is 30 days, 30 Earth days. But here we have the same amount of a day on it makes a circulation for Saturn, which means that over this composition, Titan is not a moon which orbits on its axis. And that's pretty cool, right? I mean, it doesn't orbit over on its axis. And Titan is composed, the composition of Titan is known to be a very rocky water ice over a rocky interior. Its surface has liquid hydrocarbon lakes and the vents of volcanoes distributed among areas of the bright and dark terrain that show the evidence of some impact cratering, even though you look at this photo and it looks like there's no impact at all. Titan is also covered with a thick atmosphere that some consider to be similarly that of Earth's, of early Earth. I don't know if it was Titan, but there is like talks about a habitable small moon planet, even though I would say Mars is the better habitable planet thingy here. But there are talks, yes, about like habitable planet being like Titan, Saturn's largest moon, even though it's not really that much. And now let's get into Saturn's orbit. Now, as you can see in this photo, at the start of the orbit, it's 1862, and then it goes around, and at the end of the orbit, it would be about, after 1885, so that'd be, so 23, so about 1891, after he finishes the orbit, because Saturn has a 29.4 year orbit, so which means after the sun, by the time Earth makes 29 orbits, and a guy on Earth is already 29 years old, like he's already big grown up, Saturn has still got a 1-year-old baby, so that is sad. But just watch how sad the other two planets are if Saturn's that sad. And Saturn has an oval-shaped storm similar to Jupiter, but its gas giantiness and the stuff of that makes it so that it only has the 1/8 average density of Earth's, which means Earth, however, with its larger volume, Saturn is over 95 times more massive, because Saturn is more massive because obviously the gas giants have more mass. As you can see, Jupiter literally killed the mass bar on it. But if you're talking about Saturn's mass is 95 more massive than Earth, but it's still not even half as big as or massive as Jupiter. And anyway, we get back. One day on Saturn equals 10 hours and 39 minutes, which means Saturn is the second fastest spinning planet, because the first fastest spinning planet is Jupiter. Now, like, hey, isn't it Mercury? Well, that's a whole other story. That's the speed of the spinning. This is a day spinning, because a day on Mercury is really, really long, more than many, many Earth days. But this here, a day on Saturn or Jupiter, is literally not even half an Earth day. So that would be something to say. That is something to achieve that you're really fast, Saturn. And Saturn's axis tilt is 26.7 degrees. I told you Mars's axis degree tilt was 25.5, but Saturn's axis degree tilt is 26.7 and Earth's is 23.5. And you should never forget to talk about the rings of Saturn. Now we got that full photo here. Saturn has its rings. Basically, you should never forget about its rings because Saturn is the master of having nice rings. Even astronomers at the first saw it all the way back in the 19th century. They couldn't even stop talking about how beautiful it was and all the rings made out of billions of pieces and ice and dust and rocks. Overall, Saturn is really good, and it is the second biggest planet. It's got really good rings. And now let's tell you how the rings were formed. Basically, Saturn and every planet has something called a Roche limit, or however you pronounce it, but it's basically the limit where Saturn's or whatever other planet's moons, if they come together and they cross that Roche limit, they would be crushed into pieces and be ripped apart. And now let's just say Saturn has a huge Roche limit because it got such a big Roche limit that there's debris of moons from Saturn which crossed the Roche limit of Saturn. They turned into pieces, like basically forming real big rocks and debris and icy debris everywhere, which makes Saturn the beautiful rings it has. And basically, that is really good about Saturn, because they got rings, and it's the only planet, well, not really, because Jupiter, Neptune, and Uranus, all these big planets also have rings, but the point is Saturn's Roche limit is that of which is really big, so that Saturn, it has its Roche limit big and it gets its rings, because again, Jupiter, Saturn, Uranus, Neptune all have rings, but Saturn is one that's really big, so that so a quick review here before we go into some other big facts about Saturn and some other stuff maybe. Saturn is the 6th planet from the Sun and 2nd largest planet in the solar system after Jupiter. It is a gas giant with an average radius that of 9 times of Earth. It has 1/8 the average density of Earth. However, with its volume, it is 95 times more massive. And again, main moons, we got Helion, Pythias, Prometheus, Janus, Dione, Tethys, Enceladus, Titan, Ipius, Rhea, Mimas, Hyperion, Methone, Pandora, Calypso. And that is a fact about Saturn. And now, why is Pluto not a planet? It's our favorite dwarf planet since 2006. Pluto is an icy dwarf planet in the Kuiper Belt, a ring of bodies beyond the orbit of Neptune. It was first and the largest Kuiper Belt object to be discovered. Pluto was discovered by Claes Tombaugh in 1930 and declared the 9th planet from the Sun. Of course, until some other astronomers came along and defined the planet's new definition as a planet must have the orbit around the Sun must be spherical. Now Pluto, of course, is spherical. It does orbit around the Sun, but it can't clear its path of other icy debris where the Kuiper Belt is, and there's rocks, comets, and asteroids clear of icy debris. So until Pluto clears all of that, it is still a dwarf planet. Sadly, bye-bye Pluto. But as Earth has cleared its icy debris path, so no other debris is gonna come in to the orbit of Earth, and Earth will be safe from not being called a planet, which we all do not want that to happen. I don't even know if we all humans will just be like, we're gonna be too sad to even think about Earth not being a planet. They just make it a planet for no reason. They just change the planet definition. That's like my experiment, like my hypothesis of what humans would do if Earth was like declared not a planet, because all of a sudden some kind of comet appeared in its debris. And Saturn is the sixth planet from the Sun. It is the second largest planet after Jupiter. Saturn is named after the Roman god of wealth and agriculture. Its astronomical symbol H represents the god's symbol. Saturn's interior is mostly composed of a core of iron, nickel, and rock, and silicon and oxygen compounds. Its core is surrounded by a deep layer of metallic hydrogen, an intermediate layer of liquid hydrogen and liquid helium, and finally gaseous water layer. Saturn has a pale yellow color, so as you can see there, due to ammonia crystals in its upper atmosphere and electrical current within the metallic hydrogen, which is thought to give rise to Saturn's planetary magnetic field, which is weaker than the Earth's but has a magnetic moment, are you ready for this, 580 times that of Earth's due to Saturn's larger size. Saturn's magnetic field strength is around 1/12 of Jupiter's. The outer atmosphere is generally bland and lacking in contrast, although long-lived features can appear. Wind speeds on Saturn can reach hours reported. A day on the Saturn has to be determined in 10 hours, 33 minutes, and 38 seconds. Based on the studies of Saturn's sea ring. The planet's most famous feature is its prominent ring system, which is composed mostly of ice particles with a smaller amount of rocky debris and dust. At least 82 moons are known to orbit Saturn. I said 62, but it's 82 now, because I realized that after further research, because before I used to say that was 62, I just remembered that a few days ago I was thinking 62 for too long, and I was still saying 62 at the beginning of the video, so too bad for me. Oh my god. And yes, Titan, Saturn's largest moon and second largest solar system, is real big. And if you wanted to know how far Saturn is away from the Sun, of course, it is 10.238 AUs. And that's really big because it's 10 AUs. Remember, Earth is 1 AU. And the outer atmosphere of Saturn contains 96.3% molecular hydrogen and 3.25% helium by volume. The proportion of helium is significantly deficient compared to the abundance of element in the Sun. The quantity of elements heavier than helium, metallicity, is known not precisely, but the proportions are assumed to match the primordial abundances from the formation of the solar system. The total mass of those heavier elements is estimated to be 19 to 31 times the mass of Earth, with a significant fraction located in Saturn's core region. And Saturn's atmosphere is a banded pattern similar to Jupiter's, but Saturn's bands are much fainter and much wider near the equator, and the nomenclature used to describe these bands are as the same as Jupiter's. Saturn's finer clouds patterns were not observed until the flybys of Voyager spacecraft during the 1980s and 1970s. Since then, Earth-based telescopy has improved to the point where regular observations can still be made. The composition of the clouds varies with depth and increasing pressure in the upper cloud layers, with the temperature in a range to 100 and 160,000 pressures extending between the 0.5 to 2 bar. The clouds consist of ammonia ice. Water ice clouds begin at a level where the pressure is about 2.5 bars and extended down to 9.5 bar, where temperatures range from 185 to 270 K. And determined that this layer is a band of ammonium hydrosulfide ice laying down the pressure at 3 to 6 bar temperatures with 190 to 235 K. Now, finally, the lower layers of the pressure between 10 to 20 bar are the biggest ones. 270 to 330 K contains a region of water droplets with ammonia in aqueous situations. Saturn's usually bland atmosphere occasionally exhibits long-lived ovals and other features common on Jupiter. In 1990, the Hubble Space Telescope imagined an enormous white cloud near Saturn's equator that was not present during the Voyager encounters in 1994, and another storm was observed. The 1990s storm was a great example of the Great White Spot. I know, even if you have a close look at Saturn, the Great White Spot, you might not see it, but you just gotta think it's there. The Great White Spot is also known as the White Oval on Saturn, named by analogy of Jupiter's Great Red Spot. Are periodic storms that are large enough to be visible from Earth through telescope. By their characteristic white appearance, the spots can be several thousands of kilometers wide. A unique but short-lived phenomenon that occurs on Saturnian year roughly every 30 years, around the time of Northern Hemisphere's summer solstice. Previous great white spots were observed in 1876, 1903, 1933, 1960, with the 1933 being the most famous. If the periodically is maintained, another storm will occur in near 2020 this year. Yeah, and if you're watching it after a long time, if you're watching my video, then it probably already occurred. The winds on Saturn are the second fastest among the solar system's planets after Neptune. Voyager data indicate peak easterly winds of 500 meters per second, which is again 1,800 kilometers. The images from the Cassini spacecrafts during 2007, Saturn's northern hemisphere displayed a bright blue hue, similar to Uranus. The color was most likely caused by Rayleigh scattering. Thermography has shown that Saturn's south pole has a warm polar vortex, the only known example to such a phenomenon in the solar system, whereas temperatures are normally minus 185 degrees Celsius. Temperatures on the vortex reach as often as high as minus 122 degrees Celsius. Of course, now nothing surprising like Jupiter, but it is still a surprising fact to know that the temperatures are reaching about minus 122 degrees Celsius, suspected to be the warmest spot on Saturn. So speaking of that, the Saturn has enormous. The average distance between the Saturn and the Sun is 1.4 billion kilometers, which is 10 astronomical units, with an average orbital speed of 9.68 kilometers per second. It takes Saturn 10,759 Earth days, or about 29.5 years, to finish one revolution around the Sun. As a consequence, it forms near 5.2 mean motion resonance with Jupiter. Which means it's in celestial mechanics. Orbital resonance occurs when orbiting bodies exert regular periodic gravitational influence on each other, and usually because of their orbital periods are mostly related to a ratio of small integers, most commonly relationship found for a pair of objects. With Jupiter that happens. The elliptical orbit of Saturn is inclined 2.48 degrees relative to the orbital plane of Earth. The aphelion and aphelion distances are respectively 9.15 and 9.195 and 9.957 AU on average. The visible features of Saturn rotate at different rates depending on latitude, and multiple rotation periods that have been assigned to various regions, as in Jupiter's case. Astronomers use these three different systems for specifying the rotation of Saturn. Saturn has a period of 10 hours, 14 minutes, and 0 seconds, and encompasses the equatorial zone, the south equatorial belt, and the north equatorial belt. The polar regions are considered to have rotation rates similar to System 1. All other Saturnian latitudes, which I'm showing on screen right now, are all the other Saturnian latitudes, excluding the north and the south polar regions, are indicated as System 2 and have been assigned to the rotation period of 10 hours, 38 minutes, and 25.4 seconds, which is the one I told you earlier. And System 3 refers to Saturn's internal rotation rate based on radio emissions from the planet detected by Voyager 1 and Voyager 2. System 3 has a rotation period of 10 hours, 39 20 and 22.4 seconds. System 3 has largely superspeed System 2. Radio rotations of Saturn have appreciably increased to approximately 10 hours, 45 minutes, and 45 seconds. So, but the last the Cassini, Voyager, and Pioneer probes were reported in September 2007, and it is 10 hours, 32 minutes, and 35 seconds. So there you can tell a whole story if someone ever asks you about how long a day on Saturn is again. And in March 2007, it was found that the variation of the radio emissions from the planet that did not match Saturn's rotation rate. This variance may be caused by geyser activity on Saturn's moon Enceladus, which is the sixth largest moon of Saturn, is about 500 kilometers and 310 miles in diameter, about a tenth of that of Saturn's largest moon, Titan. Enceladus is mostly covered by fresh, clean ice, making it one of the most reflective bodies of the solar system. And the water vapor emitted into Saturn's orbit by this activity becomes a charge drag upon Saturn's magnetic field, slowing its rotation slightly relative to the rotation of the planet. Okay, so as you can see, there's many angles, there's like the latitude and multiple rotation periods, and there's also something called the polar aurorae, or the magnetosphere, in the main magnetic sphere of Saturn. Saturn has an internal magnetic field that has a simple symmetric shape of a magnetic dipole. At the strength equator of 0.2 Gauss, it is approximately 1/20th or 12th or 20th of the field around Jupiter, slightly weaker than Earth's magnetic field. As a result, Saturn's magnetosphere is much smaller than Jupiter's. When Voyager 2 entered the Saturn's magnetosphere, the solar wind pressure was high, and the magnetosphere extended by only 19 Saturn radii, or 1.1 million kilometers. Although it enlarged within several hours and remained so for about 3 days, most probably the magnetic field is generated to similarly that of Jupiter's, but by currents in the liquid metallic hydrogen called a layer in the metallic hydrogen dynamo. This magnetic field is efficient, deflecting the solar wind particles from the sun and the moon. Titan orbits within the outer part of Saturn's magnetic sphere, contributes plasma with the ionized particles on Titan's outer atmosphere, and Saturn's magnetosphere, like Earth's procedures, are on the aurorae of Saturn, which is the polar aurorae of Saturn. And Saturn's North Pole and Saturn's South Pole usually are really different. Now, Saturn's South Pole is not that animated or moving it doesn't got that many storms. The South Pole, and if you look in the North Pole, I'd say the one that we're looking at the photo right now, it is really animated. It's got more storms and all those stuff you can talk about for Saturn's North Pole. Now, I'm not going to talk much about this because we got to end the video soon. The North Pole has a hexagonal cloud pattern, and the South Pole has a vortex, which means they're just saying the North Pole, or I'm just saying the North Pole has more of storms than the South Pole and Saturn. And so, anyway, now that we're at the end of the video, since it's been so long since I released Jupiter, I'm finally releasing Saturn. Thank you all for watching. Thank you so much. And just don't forget to drop a like on that video. Don't forget to just share it with all your friends. Make sure they all see it. Don't forget to comment down below how Saturn is. It's a nice planet, of course. And also, don't forget to subscribe to Gamer123ST. And just peace out, everybody.